Hi. Hi. So we are going to present the ILC2 of System Verilog, and the topic which we have chosen for the ILC is Semaphore, and we are a group of two, me, Nisha Shetty, and my friend Amarjit Shinde. So our PRN numbers are 1805050 and 1805041. So the contents of our topic are semaphore syntax, semaphore methods, and the semaphore example. So let's dive in contents one by one. So our first one is, what is semaphore? So semaphore is a system Verilog built-in class used for access control to shared resources and for the basic synchronization purposes. It is like a bucket with a number of keys. Processes using semaphores must first procure a key from the bucket before they can continue to execute. All other processes must wait until a sufficient number of keys are returned to the bucket. Imagine a situation where two processes try to access a shared memory area, where one process tries to write and the other process is trying to read the same memory location. This leads to an unexpected result. A semaphore can be used to overcome the situation. Next one, we will see the syntax of semaphore, which is semaphore space semaphore underscore name and a semicolon. The next one is semaphore methods. So semaphore is a built-in class that provides the following methods. The first one is new. It is used to create a semaphore with a specified number of keys. The next one is get. It is used to obtain one or more keys from the bucket. The next one is put. It is used to return one or more keys into the bucket. And the last one is try underscore get, which is used to try to obtain one or more keys without blocking. We will see each of these built-in class processes in detail. The first one is new. So the new method, it is used to create the semaphore, and its syntax is semaphore underscore name, which is equal to new in parenthesis numbers underscore of underscore keys and a semicolon. The new method will create the semaphore with number underscore of underscore keys in a bucket where number underscore of underscore keys is integer variable. The default number of keys is 0. The new method will return the semaphore handle or null if the semaphore cannot be created. The next one is put. The semaphore put method is used to return key or keys to a semaphore, and its syntax is semaphore underscore name dot put in parenthesis number underscore of underscore keys and a semicolon. When the semaphore underscore name dot put method is called, the specified number of keys are returned to the semaphore and the default number of keys returned is 1. The next one is get. The semaphore get method is used to get key or keys from a semaphore. Its syntax is semaphore underscore name dot get in parenthesis number underscore of underscore keys and a semicolon. When the semaphore underscore name dot get method is called, if the specified number of keys are available, then the method returns and execution continues. And if the specified number of keys are not available, then the process blocks until the keys become available. And the default number of keys requested is 1. Try get. The semaphore try get method is used to procure a specified number of keys from a semaphore but without blocking. The syntax is semaphore underscore name dot try underscore get and in parenthesis number underscore of underscore keys and a semicolon. When the semaphore underscore name dot try underscore get parenthesis method is called and if the specified number of keys are available, the method returns 1 and the execution continues, and if the specified number of keys are not available, the method returns 0 and the execution continues, and the default number of keys requested is 1. And the next part will be explained by Amarjit.
So now let me tell you what semaphore is. Suppose the resource is very limited and we have process which is trying to access the same source of the same time. Consider a resource as a memory and there are two processes, write and read. At the same time, if you are doing write and read, both this will lead to conflict. It will give some garbage value. Then in this case, semaphore is used. Suppose you have a bike and there are two friends which need a bike, but you can only give it to a single person. In such a case, semaphore creates a bucket in which key is present and a single person uses this key. When this key is used, it is again put into the bucket so that the other person can take the key. Now let's go towards the code part. Here model test bench is created. We have used new method to create keys. In initial begin and end block we have created two processes by using the fork and join so that all the process will run at the same time, and we have repeated the processes two times. Let display first and consider A as the process where A is trying to get the key. For getting key you need to use key.get, which is a semaphore. By this we will get the key. Then after getting the key, we did here the work for 10 milliseconds, and again we have wrote key.put, which is a semaphore used to put the key back, and we have displayed the time for how long it has taken to execute. In this similar manner we have created the processes for B. In such a way we have created two processes A and B. For the output, let's go towards the simulation. So we have simulated this in EDA playground. So let's run the code. As you can see here, process E is trying to get the key at time 0 and process B is also trying to get the key at time 0. But process A have got the key at time 0. This means that the process B will not get the key, and A will use this key for 10 milliseconds. Therefore, process A has written back the key at 10 milliseconds and process B will get the key at 10 milliseconds. After using this key for 10 milliseconds, process B has written back the key at 20 milliseconds. Similarly, at 30, you can see that process E is trying to get the key and process B is also trying to get the key at 30. But process A got the key at 30. This means process B has not got the key, and process A will use the key for 10 milliseconds and return it back at 40. As you can see here, process E has written back the key at 40, and now the process B will get the key. In such a way, semaphore is used when single persons needed a key, two persons needed a key at a single time. Thank you.